So this is Anthony, pronouns he, him, from Virginia. He is a theist, and he wants to know what our best evidence for evolution is. Is that not so exciting? Are you not just champing at the bit? So let's invite Anthony. All right, Anthony, can you hear us? You are on Skeptalk.
I can hear. Yes, I can hear you. Can you hear me?
Wonderful. I can. You're a little bit staticky. If you're on speaker, you might want to try being not on speaker.
No, it's just like that. Yeah, it's just a bad connection and maybe it's a bad phone. This has been an issue. So hopefully if it gets too bad, let me know and I'll try to I think sometimes holding the phone farther away from my mouth helps a little bit.
If you did that just now, it worked.
Okay. I'll try to do it. I'll try to hold it like this now. All right. So, my question is, as you said, I want to know before you answer, let me give my question and then kind of a little bit of details, and then I'll let you go. What is the best evidence for evolution? And I just want to say outright that I've looked into the evidence for evolution. I don't see anything that has convinced me yet. But I guess my question is, if we use the definition of a change in allele frequency in a population over time, I completely accept that definition of evolution, and I think there's a lot of evidence for it, and it's strongly supported by science and observation. But when we define evolution as kind of a descent from a universal common ancestor where creatures can evolve into completely different kinds, and I know that word kind is kind of like a difficult to define word, that's the kind of evolution I don't see any evidence for. So my question really specifically is there any observed evidence that's not based on inferences about things that happened in the past that shows that one type of creature can evolve into another type of creature? So, and I know you probably think there's a lot of evidence, but maybe we'll be able to go through a couple of things that you think demonstrate that.
No, absolutely. I think, Jackson, you start us off. I can see those gears turning because I've got my spiel, but Jackson, this is like right up his alley. So he's gonna start us off, and he's the guest, so he gets to go first.
Oh, how kind! Thank you. I'm more intrigued by why you're taking a set of data off the table, sort of a priori. Can you explain to me why you think inference is like unable to answer this question at all, or inferences about data?
Because I think that comes more down to interpretation of data as opposed to things that we can repeatedly test. It's not that it doesn't demonstrate anything, but I really think that sometimes evolutionists, and again, I hate to use that word, but people who support evolution, they make claims about things that they think happened based on the evidence. And I think, and to me, when you're talking about things that supposedly happened millions of years ago, that's more of an interpretation rather than a hard fact. So I can see how it might convince people, but for me, it could easily be interpreted other ways. Whereas if you have something that we can look at in real time, that's much harder to deny as being a fact or true.
So I'll give you an example of why that isn't true. My go-to example for that is always index fossils. So index fossils are, just for anyone who's not aware, they are fossils that are wide in horizontal distribution. So you find them all over, but in a very small window of time. So for instance, like you have different species of conodonts, which are these little jawless fish, or different species of ammonites or snails or what have you. There are lots and lots of different organisms that fall into this category. They're typically invertebrates, although there are a few vertebrates who meet that definition. And these organisms are stratified in the geologic column, not by size, but by species. So there's no explanation from creationists, as far as I've seen. I mean, there are some extremely tortured attempts at explanations for this distribution, but the favorite one that people always go to is, oh, what about hydrologic sorting? Well, that doesn't work because many of these are very nearly the same size. So you're not going to get hydrologic sorting by species. That's just not how water works or sediment deposition. So I'm curious to know what a creationist explanation of the existence of index fossils could be.
Are you asking me?
Yes.
Okay, yeah. So, Anthony, you're the the sound that we're getting from your end too is like pretty bad. So I've been sort of asked to keep the answers like kind of concise from you, and I know that kind of sucks, but just because it's like pretty loud and like kind of abrasive. So if that's okay, just try to be like as concise as you can be.
Okay. Oh, okay. Yeah. And all right. Sorry about that. I hate that these audio issues are a problem, but
Yeah, I do too. That sucks.
so okay. Well, we'll try. We'll keep trying. So basically, an index fossil is a fossil where there's similar kinds of creatures, but they're definitely different species that are arranged in an increasingly complex, increasing
Not
complexity based on
necessarily.
their. But there's a geologic column, and they're stratified according to that geological column, right?
They are stratified according to their species. It's not necessarily an issue of complexity, because complexity, we don't really have a good definition of what complexity is, and I don't think that's a really relevant issue here. The point is simply they're stratified by species. That's what I would say.
Okay. So I guess my question would be, and again, not being an expert, I don't know all the facts, so I'm really just trying to get information. Is there like
Okay.
a fossil deposit where there was like a very clear lower layer and then like an upper, you can see the different layers, and all of these creatures exist in that same place, and as you get closer to the surface, there's different species arising. Is that something that
You mean like, are they
exists?
stratified by like where they are in their environment?
I guess I'm asking, like, is there literally a location on Earth where you can see this stratification, or is it like they found a strata in England? Okay, so they will dig. So what they do is they dig down and they find a strata, like 20 feet down there will be one stratum, and then 16 feet there will be another stratum, and they have different.
Yeah, you can do like sediment cores. Yeah.
Okay. I guess. Well, I'm not a young Earth creationist, so it seems to me that
that's kind of like a good. I think that's good, but like I think that a critical point here, right, is like because you aren't a young Earth creationist, right? What Jackson is saying about these index fossils, and not only are they index fossils in the sense that you've got this clear connection and multiple different local areas that unite them temporally, but they also evolve through time, right? So you can core down to like through multiple different levels, crossing dozens of index fossils, and you can see a form of for lack of a better term, plankton, right? Change shape and form as you move up, change size, change specific adaptations for the type of environment that it's living in, which can then be cross-checked with the isotopic analysis of the environment that it is found within, right? So the case in point being, you're seeing organisms respond to change in time, changing through that time, and that is being cross-checked with the environment itself. So to Jackson's point here, right? You're seeing this change over time. And I would assume that your answer to this would be like, well, okay, but it's not becoming anything else, right? But that's not really what evolution ever actually says, right? You don't outgrow your ancestry, for lack of a better term. Organisms adapt and change within their environments. And the issue from the sort of alternative perspective here, the intelligent design advocates or the old Earth creationists, is that we see change constantly in real time, and we see it through the fossil record. It meets predictions we've made within the fossil record, and there is no genetic or otherwise stopping point that seems to prevent change up to a certain degree, right? Like there is no genetic barrier that you can find that says organisms can only change this much before it becomes too much, right? And we've seen this as well in the lab, right? Where you can take like Hox genes, body plan genes, and tinker with them. And under manufactured pressures, you can see these certain characteristics that show up randomly or are introduced artificially speaking, take hold and fix in the population. So the point is Jackson's index fossils are like a wonderful example of multiple different sort of disciplines coming forward and converging on evolutionary theory being responsible for biodiversity today.
So I may have misunderstood. I apologize if I did. That was my fault. I thought that you were contesting evolution because you were a creationist. That's why I went with. I was more asking why you. Why
I am a creationist.
No, a young Earth creationist. I thought you were a young Earth creationist.
Oh no,
that's why I went.
Okay, no.
That's why I went to that because I was confused about why you were taking inference off the table. But since you're not a young Earth creationist, I mean, you can very easily accept the existence of index fossils. I would say that to answer your original question, then the example that I would use would be.
Well, can I stop you for a second? Because I just want to ask about this. I just want to ask more detail. I haven't studied this. Is the type of creature you mentioned? What was it? A convid or a
conodont?
Conodont. Conodont.
Okay. Oh, conodont. Okay. So would this fall within the same? Would these organisms that we've found fall within the same range of diversity as, say, a dog in the different dog breeds?
No, these are species to species transitions.
Okay, so they're
dogs are all within the same species, Canis familiaris or Canis lupus familiaris, whichever one.
Well, and dogs tend to be a poor example of this. Like I hear this from creationists a lot. Like it's like, oh, if you found all of these different dog skulls in the fossil record, you would think that they were different species. Well, if every dog breed that we have today lived in the wild and they weren't the result of artificial selection, kind of maximizing the type of phenotypes that you can see within a single species, that species being determined more or less genetically in the case of dogs, like in the wild, a Chihuahua is not actually capable of reproducing with a Great Dane. They would, by the biological species concept, if they were in the wild, be considered separate species. Unequivocally, they would be. Right? Now, if you want to say, okay, well, if organisms can only like theoretically reproduce, like with in vitro fertilization, well, then your definition of species becomes so incredibly squishy because that type of reproductive barrier is so flexible and fluid, even within singular families, right? Like, so what I'm saying is a dog isn't exactly the example that I think creationists tend to think that it is, because it only works using like colloquial understanding of hybridization and species concepts.
Okay. And also species aren't real. Who said that?
And also species aren't real. I'd like to, if I can, Anthony, I'd like to give you my best evidence for evolutionary theory. And I think Jackson will agree with this because it's extremely like intuitive and simple, right? It is the genetic unity of all life, right? No matter how you frame it, no matter what type of phylogenetic test for phylogeny that you're trying to run, organisms fall into nested hierarchies. And they fall into these nested hierarchies within their functional DNA and within their non-functional DNA. And that latter half is really important because you can't argue for common design in the latter half. Right? You might say, okay, well, organisms look similar and they appear to be similar genetically because they are designed commonly by a singular creator. Well, that makes sense for the genes that do something. But for the genes that are, for all intents and purposes, evolutionary leftovers, under a design model, those should not fall into a nested hierarchy and appear to be evolutionary in nature because they don't actually have a purpose. And we know that these regions are non-functional due in part thanks to knockout tests and things of that nature. But people have done statistical analyses on the types of like sections of genomes, right? You can consider them to be like ultra conserved regions of the genome. And folks have done statistical tests to see how likely is it that we would see the pattern that we see within all of the tree of life today if it is not the result of common descent. And that number is equivalent to picking the same atom twice subsequently in the universe with all of the atoms at your fingertips, right? It is absolutely incredible how precise the nested hierarchies are that we produce in genetics, right? And my area of specialty is primates, right? I'm a primatologist. I'm trying to get my degree right now in biological anthropology. So there's a really nice paper that actually Jackson pointed out to me years ago that took that exact concept, these nested hierarchies in constrained and unconstrained regions, and they said, how about we take it to the next level? We're going to compare that signal to morphologic or physical similarities between organisms and biogeography where they're found. And we're going to specifically test the evolutionary model of common descent with all of these organisms and all of these critters and those separate signals with separate ancestry at the family level, which is what creationists typically propose is the level of these created kinds. And they were able to overwhelmingly reject family level separate ancestry because of the infinitesimal p-value that their analysis actually produced, right? Like the odds of getting the data set that we see with a separate ancestry model, with Cercopithecidae being a separate family from Aotidae or Atellidae and Hominidae, it's not going to work mathematically speaking. And to me, that's the best evidence for evolution, that genetics on its own seems to just scream at us that organisms are all related in areas of their genomes that do things and in areas that don't do anything at all, again, negating the common design theory, and that this is corroborated by where the fossils are found, if we're looking in the geologic column, and by the physical characteristics of the organisms themselves. And to add a cherry on top, in hominid evolution, this is also corroborated, or I shouldn't say corroborated, this is also supported by the fact that most of the time when we're looking for transitional species, whether it's in hominins or whether it's in tetrapods or whether it's in, quote unquote, dinosaurs to birds, archosaur lineages, we'll say, we predict where these fossils should be based off of evolutionary assumptions. And then we go out and find them where they would be under evolutionary assumptions, right? Creationism does not do this. And they also don't have very much success in finding these types of fossils. They have to use evolutionary preconceptions to even interact with the data. So to me, all of those things together seem to just point a big neon red arrow at ding, 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 common descent, right? All organisms share a ancestry.
To add to that, there was also a paper that came out in 2022 that compared trees based on, phylogenetic trees based on molecular data sets, morphological data sets, and biogeographic data sets. And you do get congruence among all of these. And the paper found that, interestingly, biogeographic data sets concur with molecular data sets more often than morphological ones. But of course, there is overall congruence among all of these. So yeah.
All right. Well, that was a lot. So, okay, I see which. There are basically two main points that have been brought up that I would like to engage with, and one was one that Erika brought up in an earlier part of the conversation, where she said that there's no limit to kind of this evolutionary process. Where, I think that's suitable, but your most recent point about nested hierarchies and the stuff about non-coding regions of DNA is interesting, but let's just take as a general principle and this is why I'm talking about. To me, that doesn't convince me at all, because as you seem to be aware, this could just as easily be explained by common descent. If we just take as a general principle the idea that organisms that are morphologically more closely related, you would expect they would be more also closely related genetically. They'd be using the same kind of code because
Anthony,
they have.
Yeah. So your problem with that, though, is like, and I appreciate that. Like, what I gave you is an info dump, right? My hope is that if you feel so inclined, you can go back and rewatch this and go look into some of that, right? Because to me, evolution is best supported by the tapestry of multiple different disciplines that all converge. It is that convergence of different disciplines that is the singular best evidence, not any one discipline working in isolation. But to your point there, the information is new, so like I can appreciate why it might not it might take a couple of listens, because it certainly did with me when I was first introduced to the argument. But it couldn't be common design. Like what I'm telling you is it literally cannot be common design because of those unconstrained regions, or excuse me, like non-functional is probably a better way of putting it for this conversation. Those non-functional regions also form nested hierarchies, right? So the regions of the DNA that don't do anything also recapitulate evolution. You, as a common design advocate, can only use the functional regions of the DNA because those are the regions that are responsible for sort of the nature of the thing, the archetype of the animal that you're considering, right? The phenotype, as it were.
Yeah.
But those non-functional regions form the same nested hierarchy that falls in line with evolutionary theory, and specifically evolutionary theory as it has been and was originally predicted by basically every evolutionary biologist, right? Humans being aligned closest to the other apes, and then to the catarrhine monkeys, and then the anthropoids, and then so on and so forth, all the way up through the strepsirrhines, and then mammals, and all the way down the line, right? So design doesn't work because before genomes were sequenced, right, before that technology was readily available, before 2005, the Kitzmiller versus Dover trial, the common design advocates, the intelligent design proponents, were extremely clear that common design works because the regions of the genomes that are functional and do things are basically only appearing to form these patterns. But when the stuff that also doesn't do things forms those same patterns, you run into a bit of a problem, right? Because then you've kind of got a trickster going on with God, where he's saying common design for the things that do things, but also common design for the things that don't. All of it just appears like evolution. All of it just seems to look like evolution for no actual biological purpose.
That sounds to me like a theological argument and not a scientific argument. When you say, well, I don't think God would have done something like this because that would be deceptive of God. And go ahead, Jackson.
So I think I understand where you're going, but I think you're misunderstanding. That is a scientific argument. You can make a prediction. Well, I mean, it's kind of the problem. You have to figure out what the characteristics of the designer are, which, would probably be a theological thing. But what Erika's talking about is you can make predictions about what we would expect under evolution versus what we should expect under design, or what we could expect under design. Design can functionally predict anything. Design can predict any pattern and no pattern. Evolution can only predict one pattern, and that's the nested hierarchy that Erika is talking about.
Well, I disagree. I think the problem is that the nested hierarchies fall within the realm of both creationism and evolutionary predictions. So I don't think it establishes either side's point.
So I've heard that recently, Anthony. There's been an attempt to try to turn this into non-discriminatory evidence. But what I think a lot of creationists forget is that the nested hierarchy that is universal to the tree of life has been the main point of evolutionary theory since its inception. And creationists have been dragged kicking and screaming into accepting, first, that species aren't fixed. Second of all, that change can occur at the genus level, and then at the family level. And now you've got some creationists who will even accept phylum as the basis of the kind, and they'll place it at the Cambrian explosion, right? So they're being dragged kicking and screaming to accepting each and every aspect of this. But what Jackson said is true. Evolution makes one prediction. It predicts one kind, if we're talking about common descent, the common descent taxon, one type of pattern, that all organisms are related and that their genomes form nested hierarchies in functional and non-functional regions alike, and that those two nested hierarchies are the same nested hierarchy. And that is precisely what we see with zero exception, right?
I think here's the thing. I think you're wrong on the facts, because if I'm not mistaken, that within the last decade or so, due to genetic analyses, first of all, something that and correct me if I'm wrong, but I remember reading a lot of scientific publications, not from creationists, that said that the tree of life concept had essentially been eroded or destroyed by genetic analyses.
That is wrong.
Yeah, that's
Okay, so
patently false.
I just did a paper, or we just watched a video about this from a Creationist channel last Thursday.
Was it Deflate? Was it Deflate?
Well, we did. Sorry, not last week. We did watch Deflate's video on it, and the funny thing about Deflate's video is I'm sorry, tangent for a moment, but all of his arguments were like either just complete quote mines about like one specific region of the tree, or he basically tacitly acknowledged that like the larger roots or stem or whatever of the tree was fine. It was just kind of like the very outer tips, which is like exactly what we were arguing. We were like, yeah, there may be some disagreement about the very end tips with like which species is more closely related, but the larger stems, there's not that as much debate over that. And he just kind of kept passing over that point. But to your question, Anthony, that just isn't correct. I mean, just do a Google search or a Google Scholar of like phylogeny 2024, you're going to find hundreds of papers probably already,
And let me ask so hold on real quick, Anthony, because I think this is important to your point, right? The nature of this being non-discriminatory, because evolution can make an additional prediction here, and we can look to an additional line of evidence, right? So if all organisms are related, then to achieve modern day biodiversity, we should see the emergence of modern forms through geologic time. And this should be in accordance with radiometric dates and molecular clocks, for instance, so mutation rates and things of that nature. And not only do molecular clocks, like when we've got the data available to us, the mutations looking at specific species, not only do they align with the geologic rates of divergence, and I'll speak for the hominins specifically, like when different hominin groups split from one another, and then when different hominid groups split from one another, when hominoids split off, like the hylobatids and things like that. Not only do all of those match, but we find the transitional fossils themselves, right? There is zero reason.
Again, you're introducing it. Okay.
Well, no, because the problem with your idea of inference here, Anthony, is that is necessarily, again, true under the evolutionary model, but there is no prediction for transitional forms under the creation model, right? So, like, this is just Lego brick on top of Lego brick that creates this wonderful citadel of thought, of theory for evolution.
Let me all right, so let me ask or say something that I think is probably going to annoy you, but this is what I'm talking about with interpretation. You interpret these fossils, and I know Archaeopteryx, I know Tiktaalik. These are things that are interpreted as transitional fossils, but there's simply no scientific empirical way of verifying that. So are these transitional creatures, or are they just kind of like mosaic creatures that have similar traits?
I'm gonna go hard on hominins here for a minute. Jackson, would you like to go first before I go on my spiel?
Okay. I mean, you mentioned Archaeopteryx. I've fairly recently become familiar with like the actual characteristics of Archaeopteryx that define it both as a bird and as an avialin, not necessarily as aves, and also as a larger dinosaur. Are you familiar with the characteristics of Archaeopteryx, Anthony?
Yeah, I know. It's basically it has the characteristics of a bird and a reptile. It has teeth, and it has claws, and it has fully formed feathers, and it looks like it moves like a reptile more so than a bird. So it could be seen as something along the lines of a hybrid creature or a mosaic creature.
A hybrid. Mosaic. Mosaic has a specific terminology in evolution. I mean, like mosaic doesn't mean like it's a hybrid. Mosaic means that your traits don't evolve all at the same rate, which is fine. That happens in evolution all the time. Okay. Archaeopteryx has these characteristics that you just mentioned, and there are lots of other ones. That all the characteristics that all dinosaurs share among them, like if you look at Tyrannosaurus, if you look at Stegosaurus and Triceratops, the characteristics that all three of them share, the three, representatives of the three major lineages of dinosaurs, those are also all the characteristics that Archaeopteryx has. Whether it's the fourth trochanter, the open acetabulum, the mesotarsal ankle joint, these are all things that all dinosaurs have, all birds have, Archaeopteryx has them also. In addition to the teeth and the bony tail and the unfused wing fingers, also like dinosaurs and unlike any modern birds, there are no modern birds that have unfused wing fingers or a bony tail or teeth. And so I don't know. I don't know how.
Let me ask this question. Let me ask this question. This is why. I know this question was asked about almost any line of evidence, but could God have created a creature with bird-like characteristics and reptilian characteristics?
Could the universe have been created last Thursday? I mean,
if God exists, could God create a creature? This is why I think this doesn't work for a theist, because according to this model, a creationist, God could have created that creature just like that, and it would appear to be a transitional form.
So,
but the problem is, hold on. Let me finish. We can't see where this creature evolved from, and we can't see that it evolved into any. Hold on, and we so
you absolutely can.
So you can see the creature from which this creature evolved, and it's a different kind of, it's a completely different kind of creature. And if there's actually a fossil that shows this transition from whatever to Archaeopteryx to the next thing, that is shown in the fossil record.
There are more basal, like avialans in the fossil record, more basal maniraptorans, more basal theropods, more basal, Ava metatarsalians, etc. Yeah, you can go in either direction. You want to go up more towards more. Yeah, like
character
more advanced.
Trait by trait.
Yeah, if you want to go towards like, okay, well, how do we get from Archaeopteryx to modern birds? You can go like, you can look at like Hesperorniths and Ichthyorniths and Antiorniths and all these other more advanced birds, or you can go the other direction. Like, okay, well, what about the dromaeosaurs and oviraptorosaurs and all the other maniraptorans? They have a set of characteristics, and theropods in general. Yeah, you can do that in either direction. It's perfectly possible.
So, let me. Well, go ahead.
Hold on, Anthony. I want to give my example here, right? And before we get started, I want to ask you a question. Are in your opinion, are humans and other apes a part of the same kind?
No.
Okay, so there is zero physical characteristic that differentiates humans from other apes, right? We are members of Hominidae. Every single characteristic that classifies and separates out chimpanzees from gibbons, from baboons, from mandrills, from any New World monkey, from tarsiers, from striped every single characteristic that applies to chimpanzees to make them unique also applies to humans, also applies to gorillas, also applies to orangutans, and if we're looking at apes generally, also applies to gibbons. So physically speaking, humans are 100% morphologically apes. And this is something that even the earliest creationists like Carl Linnaeus classically recognized. In fact, he chose to elevate the other apes up to the human level and called us anthropomorpha instead of denigrating the other apes to the exclusion of humans. We and them share every physical characteristic. This is also recapitulated in our genome. We are more closely related to chimpanzees and more genomically similar to them than lions are to tigers, than African and Asian elephants are to one another. We are ridiculously similar genomically. So this makes a very simple prediction, right? Though both of those things are true and humans are apes, then we should have fossil evidence that we emerged from a previous more basal ape and that chimpanzees did as well. And if you use the molecular clock, that puts that divergent state around 7 million years ago, which is when we find Sahelanthropus chilensis, the very first ape that is starting to take on hominin characteristics like smaller canine teeth and a more erect posture. As you continue through geologic time, going to 6 million years ago with the Rorntuganensis, 4.4 million years ago with Ardipithecus ramidus, approximately 3 million years ago with genus Australopithecus, and expanding into 1.98 million years ago with other later members of that. You see the emergence of genus Homo. These things start to stand up upright way before then. And then you see the expansion of the brain case size, the flattening of the face, the minutia of the cusping of the teeth, the encephalization on the inside with endocasts and things of that nature. All of this occurs stepwise, piecemeal, through geologic time. And you see the emergence of the anatomically modern human condition, like approximately 300,000 years ago. It's more archaic at that point, but we're splitting hairs. None of that should be true, and none of that should converge simultaneously under a model that does not have humans as sharing a common ancestor with apes, other apes.
Okay, well, there's a number of things here, and I want to stress again, going back to my original question. when we're talking about things that supposedly happened, millions of years, tens of millions of years ago, or hundreds of millions of years ago, I just feel like that opens up for a wide possibility for interpretation of data, as opposed to saying this is something we can observe and verify that what we're thinking is correct. So
we can observe and verify that we're apes now. Well, we're genetically and physically apes now, though, are we not?
Genetically, again, as I've said, the genetic similarities are complete. Well, hold on. Let me.
Okay, we'll finish.
When you said when you said that humans are 100% ape. Okay, well, yes. Clearly we're not. We're at least 90. We might be 99.9% similar to the other apes. But the whole reason there's a classification of humans and other apes is because
there isn't.
We're in the what she means is we're in the ape group. Hominidae. Yeah, we are 100% ape because we're in Hominidae. That's what she's saying.
We're 100% apes in the same way a dog is 100% a canine. Right? A canine is a type of animal, an ape is a type of animal. We are 100% apes, and there is zero getting out of that. Genetically, physically, through the geologic record, all of it.
We're not 100% chimpanzees, are we?
That's not what she's saying. That's not what.
Okay. So what we're dealing with? I was going to say this. What we're dealing with is an arbitrary classification system.
It's not
that doesn't demonstrate that these organisms can transition from one to the other. You can call them apes. That's fine. I think my point is that a chimp or an ancestor between chimps and humans cannot make it to humans. That's what we're trying to demonstrate. How you classify them is irrelevant,
right?
Almost.
So let's
precisely that.
Let's flip this for a second, because this is something we tried with a creationist guy I had on my channel the other day. Are you related to people to native Tasmanians? Do you share a common ancestor with people who are with native Tasmanians? Do you know?
If you go far back enough, yes.
How do you know? That was like tens of thousands of years ago. How do you know you share a common ancestor with them?
Because it makes sense that there had to be a beginning to however long ago that was. That there has to be an original human somehow.
Why?
And all humans will be descendants.
Why?
Because humans exist. So we observe humans existing. So
I've never observed the common ancestor between us and Tasmanians.
Well, okay. I would just say that
is gonna rely on inference. You know that, right? That's the point I'm trying to get at.
That's not necessarily.
And
it's not necessarily true.
You're going to rely on genetics. You're going to rely on morphology.
Yeah, and with genetics. So where does it stop? And why does it stop?
Right. So you're going to have to rely on genetics and morphology because we're humans, and what classifies us as humans is our genetics and morphology and our development. And so you're going to have to turn to that. And so we're going to ask you, why do you stop there? Why do you stop with Tasmanians, but you don't just keep applying the same logic to get us to chimpanzees?
Because we see humans giving birth to humans, and this goes back thousands of years, and we see chimps giving birth to chimps. It seems to me that we don't have any. What I would like for you all to present to me is evidence of you start with one thing and you end with another, and we've observed this.
Oh, I'm sure, I can do that. That's easy.
Okay, well, hold on. So far, I understand. Oh, let me just finish. I just want to finish. Okay. So far, every piece of evidence you've given me is based on things that you believe happened a long time ago, but which cannot be reproduced in a scientific experiment to prove that, yes, Tiktaalik is a transitional form.
You can't reproduce our common ancestor with Tasmanians.
And you've never seen someone of whatever your ancestry is birth to Tasmanian, have you?
That's true.
So we can observe humans giving birth to humans.
Not to Tasmanians.
Not a stretch to say
not Tasmanians. You haven't seen somebody, a Spanish person, give birth to a Brit. You've not seen a Native American give birth to an Inuit person. They're Native American too, but you know what I'm saying. Right. You've not observed this. Yeah. You're using inference and you're using genetics, most importantly. Why does genetics connect things, Anthony? What about genetics connects people? Why can you make a family tree? I'm curious about that. What makes a family tree? How do you do that? What tool are you using when you make a family tree or a paternity?
If you're making a family tree, it means you know who gave birth to whom and the whole lineage.
Not necessarily.
Yeah, you weren't there.
Yeah, you weren't there.
So how do you know? You use genetics, don't you? You use genetic similarity between people because you are more genomically similar to your sibling and your sibling to you than either of you is to your cousin. And then you guys as a triad are more genomically similar than any of you is to a stranger, and so on and so forth. And you coalesce on a common ancestor between the three of you. And that's how you create a tree using genetics.
We don't always have records of every person giving birth to each person. I mean, orphans happen. You know, people lose their family and, you know, when they're very young and no one has records and things like that. And so you may not know who exactly the parents may be, but you can connect that person to a population, usually the one that they're living in, through genetic testing, right? We can do genetic testing, right?
Right.
Okay, so if we can connect people to populations with genetics, even though no one may have witnessed, we have no idea who this person's parents are or their grandparents or who their relatives are, but we can still connect them genetically to a population. Like you agree that that's okay, right? We can do that.
I would say that that's acceptable, right?
Well, let me add something onto that too. Like, just as a quick thing, Jackson, right? Like, you can do that with dog breeds too. You can take different dog breeds, map their genome, and create a phylogenetic tree with dog breeds, despite the fact that they are physically incredibly divergent from one another. I would wager that there's more physical difference between a Great Dane and a Chihuahua than there is between a human and a chimp. And you accept that genetics and morphology can create a tree that way, don't you? Even though you weren't there to see the emergence of every breed.
Right. So, yeah, I would agree that dogs, we can trace them back to probably a common ancestor. Yeah. So
we can connect populations, different, you know, breeds or varieties or whatever. So we can do that, even though, again, we haven't directly witnessed either of these things.
I think when you talk specifically about dogs, what we observe is in conflict with what Erika said earlier, is that there aren't any limits. We've hit the limit. It seems
How do you know?
Why does a dog?
What data are you drawing on?
Yeah, we see new dog breeds every single year. Well,
I'm just saying. Tell me something that dog breeders have created that isn't clearly, you know, a dog.
That's not possible.
I know that.
I mean,
I'm just saying, like, evolution says that, you know, we should be able to get from like a rat to a dog or something like that. I know that's not what is claimed.
Hold on. I'm so sorry, Anthony. You went from a gray wolf to a freaking chihuahua. Is that a joke? Are you kidding me? That's basically a rat.
Have you ever seen how big gray wolves are? Like, when I stand up, they're like up to here on me.
Well, and besides that, again, the difference between a gray wolf and a chihuahua is larger than the difference, if you're just counting off morphologic traits, the difference between a human and a chimp. So by your own logic, even if you couldn't get all common ancestry, which I think we've demonstrated by several different lines of evidence that that's certainly where the arrow is pointing, you can at least get from a chimpanzee-like critter to a human.
I don't think so. I think that
why not? You think you can go to a chihuahua from a gray wolf, don't you?
Yes,
unless you don't accept that chihuahuas are descended from gray wolves.
No, I do. I think that they are, and I think that genetic analyses have been done, to, you know, demonstrating that we know basically what genes mutated. This is what I'm talking about. They know when they look at a chihuahua's genome, they can see exactly what changed between that creature and the wolf.
Ding, 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 ding. That's how you know that humans and chimpanzees are related, because the difference between humans and chimps is smaller than that between African and Asian elephants, which I would wager that you would consider to be related, between lions and tigers, which I would wager that you would consider to be related, and baboons and macaques, which I would wager you would consider to be related. So now you've got genetics and morphologic differences both being spanned like within the bounds of things you already accept, which leads me to say the only reason you don't accept humans and chimps is because humans are involved and you think humans are special.
No, that's not it at all.
You allow for a great deal of it. What's the difference?
The difference is that as you get farther away from the wolf prototype, the organisms become less and less fit, and they start to develop all sorts of. Hold on, let me say why I believe what. Okay, well, is a Chihuahua as fit to survive as a gray wolf?
In its environment? Yeah.
What's fitness? How many Chihuahuas are on the planet and how many gray wolves are on the planet? And which one is more fit?
Okay, I know. Let's I understand that. But we're talking about in a natural environment where these things would have had to evolve.
No, because that's not where dogs originated. Dogs did not originate in natural environment. They originated under the care of humans. So this is a nonsensical argument.
That's why basically all dog breeds are less fit than
has nothing.
Wolves
what is fitness?
Natural.
Answer Erica's question. What define fitness, please?
What is fitness?
What was the question?
What is fitness in an evolutionary sense? What is fitness?
Fitness is the ability to survive and reproduce in an environment.
Okay, so to again ask Erica's question, how many Chihuahuas are there on the planet relative to gray wolves?
There are a lot more, but the point is,
okay. So Chihuahuas give birth and survive, and their offspring survive way more on average than gray wolves.
So evolutionarily
then you just met the definition of fitness.
But I hold on, and we gotta bring this to a close in a second because we got a bunch of other callers waiting. And as fun as this has been, and I'm sorry to kind of cut us off here, but I think you've got like your work cut out for you here, Anthony, right? Because like you've got this range of things that you clearly accept, and I noticed that there was an interesting little route away from the topic with going from talking about change that you allow and relatedness within a genetic context to being about fitness. Right. And I'm sure that eventually that would have been a genetic entropy conversation, which is a story for another time. But I really think that you should look at the standards that you're using to assess what type of change can actually occur, because you've kind of already bought the whole cow here, at least as far as I'm concerned. Jackson, do you have anything else to say?
Let me say one more. I want to say one more thing. I just want to say one more thing, and then I'll be done. I think so. My original question was evidence that is repeatable and observable. And what I got there, you gave me a lot of lines of evidence, which are based on inference about things that happened a long time ago. But the only thing I got about current observable data is dog breed. Okay, so I just want to let you know that's where I'm at.
Well,
Anthony, you got the entire field of genetics.
I mean, most of our argument was about getting you to accept that you do allow for inference, but only for the things that you a priori accept. So, which is like, it was all special pleading. So.
Thank you for this. Anyways, Anthony, this was a great conversation. And I hope you call back next time or reach out to Jackson or I. I know both of us would be happy to have you on the channel and dissect this a little bit more in depth. Until then, take care of yourself. So, okay, he is back in the queue. Okay, I thought that was super fun. I thought that was a really fun conversation. You really hit the nail on the head with the inference thing, though, Jackson. It's interesting to see what is allowed and what isn't. And there is exactly zero objective criteria to decide what is and what isn't within his perspective.
Well, yeah. Dapper and I, when we talked to Robert, I always mispronounce his last name. Groen, I don't remember. It's Groen. I know Peter will yell at me. But yeah, what we got him to accept, just like with this guy, is it's always, and Erika, you know this from all the creationism you've read and watched, is it's always special pleading in the end. They'll always allow mice and rats to be related, lions and tigers, different elephants, but literally the exact same line of logic with no changes whatsoever connecting humans and chimps, and suddenly no, we can't do it. Sorry.
Well, and that's why human evolution is such a thorn in the side of creationism in general, because it's so personal and it feels like such a it feels like so icky to them a lot of the time. I think that it's like they're like, of course all the felids are related, of course all the canids are related, yeah, mice and rats, well, the Muridae, that's totally fine. And then it's like, oh cool, well, like humans and chimps though, right? Or hell, humans and orangutans are more genetically similar than a lot of the pairs within those families. But it's like, oh no, that is clearly very different. And it's like, it simply isn't. We have a better fossil record for humans for hominid evolution than many lineages that we have in these other major groups. We have the genomic work out the waz because we're so narcissistic, and the morphologic change fits very well within like modern dog morphologic diversity. So it's like, what is there left? As you said, special pleading, baby.
Hello, I'm Jimmy Snow, executive producer of The Line, and I only became a woodworker for the puns. That's not important. If you would like to support this channel, you can do so on our Patreon or as a channel member, and you can actually support specific shows and specific hosts in special tiers on those. Check those options out. Also, you can leave a super thanks and get a little highlighted deal. But if all else fails, you can always you can subscribe and leave a comment. Now, here are some suggestions because I don't care about the algorithm. I am the algorithm. Bye.